In this video, I'm going to show you how to install this MFC 3000 3 kilowatt fuel cell. You only need one Phillips screwdriver. So at this point, the system has arrived, it's been unpacked, and it is positioned pretty much where we want it. We will leave the system on a pallet because this is temporary, but normally we would bolt the system to the ground, but for the purposes of this demonstration we're going to leave it on the pallet. The system is in an IP45 cabinet. It's approximately 2 meters, 80 centimeters high. It's 70 centimeters across and about a meter in depth. The footprint is under 1 square meter. In terms of location of the system, all we really require is airflow to come in the front and to exit the cabinet and out the back. The system can be mounted between other cabinets as long as we have a 2 meter distance in front and behind of the system. The main access to the system is through the front door. We also have a hatch for refueling with a separate key. Inside the system we have 3 main components. The first component is our reformer, and the function of this is to convert the methanol fuel into hydrogen, which is done in real time and is determined by the load we're supporting. Behind this grill we have our fuel cell stack and our DC-DC power board, our connection to the battery point, which is through the bottom of the cabinet to here. At the bottom here I have my fuel tank. This fuel tank contains 200 litres of fuel, which we call H2Go, which gives us approximately 200 kilowatt hours of autonomy. With our 5 kilowatt system, because we have a second stack, the fuel tank is obviously smaller because we're restricted by space. At the bottom you can see the fuel pump, which pumps fuel from the tank to the reformer. This system has just arrived. There is one thing I need to do first, and that is to turn on the switches inside, and I'll explain what they do. But to get at this, I just remove the grill by flicking this latch to the right, and the grill pops out. On my left here, this is my DC-DC board. At the back is my fuel cell stack, and to the right is an external pump which we provide as standard should you want to connect a larger external tank. First switch provides power to an internal lithium battery, which is required to do system maintenance should the power completely die in the system, such as purging hydrogen from the fuel lines. The second switch is on this inverter, which we use to power the external pump. So the very first time this system arrives, you need to check that both those switches are turned on, and that's pretty much all that's required. This is the battery bank we're connecting to. This is a rectifier, and these are 3 lithium-ion 35 ampere hour battery, giving me a total capacity of just over 100 ampere hour. This would be a typical setup that you would connect the system to. Now, our system basically connects directly to the DC bus or to the battery bank. In this case, we're connecting to the battery bank. So these batteries are terminated at the back of the machine, and I have a cable coming out of the battery, which will go to my system now. So to connect the batteries to the system, I use cable. The cable that we recommend is rated for 95 ampere hour. It's AWB9 rating cable. So to connect the battery, we just run the cables up through to the connection point here. Because I don't have the batteries connected, I can do them in any order, but please make sure that the positive is connected to the positive and the negative is connected to the negative. So all that remains now is I connect the cable using the Anderson connector below, and we are now connected to the battery bank. Okay, the batteries are now connected, so all remains is for us to turn this main breaker on, and we do that like this. Okay, so the system has been turned on. We are now going through what is called a cold start, because this is the first time the system has been turned on, and what that means is the reformer is going to start building up temperature, so it's in a position to reactivate the methanol fuel. And this process takes about 3 hours, and while this is ongoing, there are some other routine maintenance procedures we can do. While the system is warming up, we're going to use the time to do some other tasks. The first one is to set up the modem. Each system we supply is shipped with an internal GPRS modem. This allows us to communicate with the system, to get status updates, to get remaining fuel levels, to stop the system by both SMS and via our website. The modem is behind the front panel here, and to get access to it, we just unlock these two clips at the top, and like so. This is our GPRS modem. It's connected directly to the Reformer controller. What I need to now is put a SIM card in, so I have a local SIM card. It's provisioned for data, for SMS, and it just slots in the bottom like so. It can only go in one way, and when you hear that click, the SIM is inserted. Okay, the other thing I'd recommend is, because you've just put a SIM in the first time, it's usually a good idea to disconnect the modem and power it on again. This basically resets the modem. While I have the cover off, I'll just point out some of these components here. This component is a blower. Its function is to blow air into the reformer, which is heated, so it's used to maintain the reformer temperature. This little black box here is a relay. Our reformer runs in 24 volts, so this converts 48 volt from our DC-DC into the reformer itself. This small PCB is a reformer controller, and this is the brains and the heart of the system. These wires come from the DC-DC bus, and these are control lines into the reformer. Two things worth mentioning: on the controller itself we have two ports. The first port here is an RS485 port, and this allows us to communicate with a local laptop via USB cable. It also allows us to trigger the system to start by connecting it directly to an AC supply. So for example, if the AC dies, the system will automatically start. This is the controller panel on the reformer. On the right side here I have a control panel, which we will cover separately. On the left side here you'll see two I/O ports. The first one is a RS485 port, which allows us to connect a computer to analyze activity of the system and to record various sensors that are inboard. The first 3 pins are for RS485, and the remaining 2 pins here allow us to connect to a DC-DC, so we can use a DC-DC failure to actually start the system automatically. The bottom connector here is basically our dry sensors, and this allows us to connect to a number of sensors to display the status of the system, to show if there's an alarm or not, to give a low fuel level warning, and an auxiliary port which can be configurable. The system is still in its warm-up phase, and one trick you can use to determine how much time you have left is to look at the control panel. It's telling us it's warming up. We set it to manual mode to effectively allow it to come straight on, and if I scroll through to the 6th screen, I will get an indication of the burner temperature and the purifier temperature. The burner at the moment is at 330 degrees, the purifier is at 377. When the burner gets to about 350 and the purifier is 380, then the system effectively will start. So we probably have another 10-15 minutes to go. Okay, about 3 hours have passed and the system has now reached its start temperature, so it is now pretty much in operation. If I look at the control panel, it tells me it's operation. It's in manual mode because that's what we set it at. And just to show the temperature of the burner is 385, the temperature of the purifier is 403. So the system is now ready to go. So now we're going to put more fuel into the system. Normally in metro areas we use these 20-litre containers to transport the fuel. When we ship the system we provide a siphon pump like this, and the way a siphon pump works is you press the siphon pump a few times and gravity does the rest. For it to work properly, ideally the level of the tank needs to be higher than the level of the fuel that you're filling. To fuel it is very simple. I just take out the filter. I take away the seal cap. I put the straight section into the tank I'm taking fuel from, and I put the hose into the tank I'm pumping to. To start the process, I just build up pressure a few times, and now gravity will do the rest. This tank only takes about maybe 40 seconds to fill. It's a very fast process. I can rotate the other two tanks, so these can be empty, no problem. The tank is fairly rigid and it has a sort of Lego brick type locking design which allows you to stack them up to a 5 high. Okay, this is just to show what's also included with your system. The first thing here is this is a siphon hose. We generally supply one siphon hose with every system. In addition, we provide a density meter, so this allows you to check the percentage of the density of methanol and the methanol water mix is correct. We have 2 sets of cabinet keys, front door, back door, and the refueling hatch. And we also have an adapter hose that would allow you to plug an external tank, which we'll show you on another video. Okay, so the system has started. It's now fully operational. I'll just give you a quick show of what's available through the control panel. Basically, the first screen tells me I'm in operation and I'm in manual mode, which is the configuration we've set it to. I also get the version number of the firmware on the controller. So the second screen shows me the output voltage, the output current, and the output pressure, the pressure of the reformer itself. At the bottom I have the ambient temperature, which is the temperature at the top measured at the inside of the cabinet, at the very top of the cabinet. The second screen is very useful. It tells me the amount of fuel remaining in my tank, and the remaining time is basically the amount of time the system can run based on the current power output. Because we're not providing power, because the AC is working, it's showing 99,000 hours. But if there was an AC outage and I was carrying a load, it would work out my remaining time to do that based on the fuel I had in the tank. We also show the actual fuel efficiency. So we basically tell you what the consumption per kilowatt hour is. Now, as the system has only just been turned on and is not actually providing power, we don't have any data for that yet, but fuel efficiency is something we can give you in real time as well. This is the total efficiency. Typically when you're running, we should see less than 1 litre per kilowatt hour. This shows me the fuel consumption since I last ran and the energy in, energy out. This tells me the number of times the system has been run, in this case 72 hours, the number of cold starts and the number of warm starts. This gives me the settings I have for actually charging the batteries. So it's basically telling me that my float charge time, the time that I float charge the batteries, is actually 10 minutes. This provides me with the temperature inside the reformer of the burner and the purifier and the catalyst. This tells me the pressure of the pump inside the system. So the pressure pump is 12 bar and the hydrogen pressure going from the reformer to the fuel cell stack is 6.6 bar. These are also various statuses which are all okay at the moment. This gives me the voltage, the current and the power output of the fuel cell stack. That is measured from the stack itself. If I had a second stack, this would give me the details for the second stack. I would have a second stack if this was a 5 kilowatt system, for example. And that is available for anybody to see on the controller menu. Okay, the second way to fuel the system is via this external refueling hatch. It means you do not have to open the front door, and the refueling hatch has a separate key. So I unlock the door. Now I'll see basically an analog gauge which will give me a rough indicator of the tank. I still have access to my fuel cap, so I take off the fuel cap, I remove the debris filter, and I start refueling. At night time you'll notice that this is all lit up, so when you open the door a light comes on so you can actually see what you're doing. And that's refueling it using the hatch. Okay, the current system has a 200 litre tank, which, as I mentioned before, will give you 200 kilowatt hours. If you want to extend that autonomy longer, it is very simply just a case of adding an external tank. This is a 200 litre external tank. It's actually part of another system, So I'm going to show you how to connect an external tank to the existing system, and it's very simply done. With the system, we provided you with this adapter cable, which has a mate lock connector on one end and a standard 4mm PVC hose. So basically, I connect the fuel line, this to my fuel line, which runs to the external tank, and I just connect this to the external pump port right here by pressing the mate lock in and pushing it all the way, and that's connected. Okay, so this is the obviously the front of the system. The system, we have the following exhaust outlets. This vent here is for the fuel cell stack. So when the fuel cell is operating, we have to lose about a kilowatt of heat per kilowatt generated, and there's a large fan behind here which blows air out underneath. To the right of this, you'll see a small little port. This is a hydrogen purge port, and occasionally you might see a few drops of water coming out, which is fine. That's the hydrogen converting into water as it passes through the fuel cell system. Above that, we have the heat exhaust for the reformer. Now, it is hot to touch, but not excessively so. We have this grill to prevent people from burning themselves. Above that again, we have a cabinet vent. So inside the cabinet, we have a fan that comes on when the cabinet reaches about 35 degrees, and its job is to blow hot air out of the cabinet. Attached to that, you'll see the antenna for the GPRS modem. And at the top of the cabinet, we have 4 lifting hooks in the event that you want to use a crane to move the system. This is the rear of the system, and as you can see, you have a door handle. Now, I cannot imagine any circumstance where a user or where an on-site engineer would ever need to get inside the back of the system, but because we have it here, I'm going to show you what's inside. First thing I need is a very small Allen key to remove this locking pin here. The door will not open without removing the locking pin, and you have to be careful because it's quite easy to lose if you drop it. Once the locking pin is removed, like so, I then just use a key to open the system. If you find the key doesn't push in one way, you turn it upside down and that will go in. You turn the key 180 degrees and the door is effectively can open. Yeah. It's the back of the system. At the top here we have the back end of our reformer. In the middle here we have the extractor fan, which is this unit here, which is in charge of pulling air through the system for the fuel cell stack. And at the bottom we have the tank. If you look just above the tank, you can see the internal fuel level sensor and the high level sensor alarm, and the air in valve. On the side of the fuel cell stack here we have a number of valves. These control the flow of hydrogen gas into the stack. This is a hydrogen pressure regulator. It would never need adjusting, it's set once at the factory, but this ensures that the pressure of hydrogen into the stack is at about 0.6 bar. This board on the side here is controls the stack and controls the short circuit of the stack. At the bottom here we have our hydrogen purge valve. So when the system is shutting down or the fuel cell is coming off, any hydrogen that's remaining inside the stack will be put through the purge valve and out to the outside. So this is the rear of the reformer. At the bottom of the reformer I have my exhaust, which goes through this exhaust port on the door to the outside. Basically methanol fuel comes into the reformer here. The reformer heats the methanol, cracks the methanol, and then the hydrogen that's produced is purified, and the CO2 that's produced is fed back in where more fuel is added as part of the heat process. The hydrogen is temporarily stored in a buffer tank. This holds about 10 litres at a very low pressure, and it is fed from here via this blue line into the fuel cell stack. In the top right here you'll see a board with capacitors on it. That provides temporary power in the event of system shutdown to operate the purge valves to allow hydrogen to be purged from the reformer. These two boxes at the top are hydrogen fuel gas detectors. They're designed to come on if there's any leak of hydrogen anywhere, and this extractor fan, which also manages the heat temperature of the cabinet, removes the hydrogen from